Hello, Internet. My name's Tom Wilson, and I'm going to talk about ADTs, or algebraic data types, for the next few minutes. I will demo um, just how you can understand them, right? They're super powerful, and once you understand them, they're very easy to use. So, what I would like to do is kind of show you guys um, what an ADT is and how you can use it in a very simple approach. And then later, I'll do another screencast on async ADTs, which will allow you to essentially compose side effects and operate on side effects without actually calling the side effects. And then once you've done all of your logic, then call the side effects, and you are essentially pushing your side effects or actions to the edges of your app and not kind of embedding it in your business logic. But first, let's talk about why ADTs. So, ADTs really gives you all of the ilities in your code, right? It creates maintainability, testability, reliability, and extensibility. Um, but learning them can be a challenge because you have to kind of change your mindset from maybe the imperative kind of style of programming that we've grown accustomed to, and really think more in terms of data flow, right? Data flowing through a pipeline. So, what we're going to do, and we're going to use Dino for this. So, I'm running Dino, and I've got a little kind of console set up. And every time I type, let's see, world, we should see it kind of pop over on the right. Um, Maybe. Let's see. I think I have to save it. That will help, right? There we go. So we've got this little demo console set up so we can go through some exercises because it makes a lot of sense when you see it in action. Um, an ADT is basically a container, and that container allows you to put values in, and then it gives you a set of rules on how you can manage, mutate, or change those values by calling methods. A common container that has very similar characteristics to an ADT is an array. So with an array, if you think of it, even the square brackets kind of look like a box. So we can basically put a value in this array like a box or a container, and then we can call map. And map is one of those special functions that when it's called, you give it a function, and that function basically has the first argument of the value that's in the container, and then you can do something with that argument. So we can, add one, right? And then whatever that function returns is what's replaced in that container as a value. Now, I know arrays can have multiple values, and when you call map on an array with multiple values, it'll actually apply that function to every value in the array. But in this case, we're only putting one value in because that's how ADTs work. Now, that value could be an array and it could do certain things, but ADTs basically allow you to stuff a value in a type, and then you can call these functions like map. And what's cool about this is so map's going to take the value 1 and place it in the v variable, and then add 1, which will result in 2, and return that and pop that back into the box. Then we can run a pop, and that's going to actually pop the value out. So if we run this, we should get an error. Let's see, we cannot read one of undefined. So maybe it doesn't like me not having a colon up here. Let's see. Okay. So we did that. Now let's assign it to a variable. That would be helpful, right? Okay. And then we'll just log that out. Right. So we get 2. And if we map again, we'll get 6, and so on and so forth. So we can chain these maps together as many times as we want, and it's always going to operate on the value and replace that value. And then using pop will allow us to extract it out. So normally in an ADT, this method would be extract. Now, another cool method in an ADT is a chain. A chain method works like a flat map. It will provide the value that's in the container, and then it will replace that value with another container. It'll replace the whole container with whatever container you return. So if we return, you know, 42, and we have to wrap it in that container, so we're returning a whole container, then it's going to replace this container that we've mapped and have done all these functions on with this new container 42. So let's see. Oh, wait. Array doesn't have a chain method. Array has a method that does the same thing as chain called flat map. So if we change this to flat map, we get 42. So basically, array is like a little, if you squint at it, little ADT, right? Um, you've got map and you've got chain, and you can kind of put values in a container. But let's use kind of or create a real ADT. And like the array, it's going to be an ADT that takes any kind of value and puts it in a container. But we're going to use an object instead of an array. So let's do that. And let's go ahead and just call it ID. So this will be ID, and it's going to take a value, and then it's going to put it in an object, and that object is going to, kind of contain the value, and it's going to have a map function, and it's going to have a chain function. And finally, we're going to create an extract function. So like the pop function, the extract function will just return the value, right? And I don't need that, I don't think. Okay, cool. So what does our map function look like? Our map function uh, needs to take a function, right? So it's going to take a function as an argument, and then we want that function to be applied to the value, right? And then we want that result to be returned into the container. And so we can do that by creating a new container and just putting that value in. And that's our map. Now, if you don't like this syntax, you can use compose or something like that. But we'll just leave that. That's pretty simple. And then our chain, basically a chain needs to return a ADT of the same type. So in this case, ID. But our function that we pass into the chain function will actually be responsible for returning that. So all we have to do is kind of call that function and pass the value. So that's super easy. And that is our new fancy ADT. It's an identity ADT. And we can do all sorts of things with it. So we can, basically uh, take our X and say ID1 map B plus 1, and then extract. If we console log X, we get, gotta save, we get 2, right? Pretty cool. Um, Now we can map again, and we can map again and again. And we can do, any function we pass in, and whatever value it returns is going to replace the value in the box or in the ADT, right? And we can also do our chain as well. So chain, instead of flat map, we grab the value and then we simply call ID and then whatever we want and return that. So then that's going to return ID 42 and ignore all the computations prior to that. But that's basically an ADT is you're taking a value, you're putting it in a container, and then you're running these functions on that. And then once you're done, you call extract. And they can get, kind of very interesting because you have this chainable interface. You can do nested ADTs, and you can kind of really add some complex logic to that. Um, Now, where it gets interesting is in the next demo, I'm going to show async ADTs. And async ADTs allow you to use the same kind of patterns to essentially wrap side effects in pure functions and run them through a pipeline. And then when you're done, actually execute the side effect functions. So that's really, really cool. Um, but for a summary, all you need to do when you start thinking about ADTs is think about this container of values, and then you're passing values um, down a pipeline of functions using map and chain, modifying the value. And yeah, that's it. Thanks.